Okay, we're going to pick up where we left off on our 1.1 notes. And so we're going to look at example 3, connecting to data. So the question is, what does 8.5n plus 5.2n plus 0.5n represent in the data display? Find and interpret the value of the expression when n is equal to 900. So if we look at this is from the Washington Public School expenditures, and we have some years on the side over here. And this down here, this tells us that this is a scale of in thousands of dollars per student that was spent. Okay, so the blue represents the instructional expenditures. Red represents the support for either staff or infrastructure, and then that was spent per student and then the 0.5, that the green there is other services, which is about $500 per student. Okay, so if we're going to look at representing this, what we're going to do is 8.5n plus 5.2n plus 0.5n, is that going to be 2019, 2016, or 2013? Well, if we look at the 8.5, the 5.2, and the 0.5, that definitely represents the year 2019. All right, so that is the year 2019. That's what the data is representing. So then if we were going to take the 8.5n plus the 5.2n plus the 0.5n, and we're going to simplify that, add together the like terms. So 8.5, 5.2, and 0.5, if we add those together, we're going to get 14.2n. 14.2n. All right, so that means basically $14,200 per child was being spent. Okay. Give me just a moment. Yeah, that's $14,200 per child. Now, let's say there are 900 students, which is what this represents here. So we're going to plug that in. So we'll have 14.2 times 900. Okay, so when we multiply that, we're going to get 12,780 when you multiply that. Let me fix that. 80. Now, that is thousands of dollars per student. So to get the total amount that was spent, we're going to multiply that by $1,000 per student. So that gives us a final answer of that was spent altogether $12,780,000 for all of the 900 students in total. That's how much was spent. Okay? Okay. Okay. So we're going to look at this next section on simplifying. Okay? So what we're going to want to do first is, and this, it printed it weird, but this is actually, what they're trying to say is x is equal to -1. That's a -1 is what that says. Okay, so as we do this right here, first of all, we want to simplify. That means we're going to find the like terms, okay? Whenever we do that, we're looking for the like terms. So on this first one, we have a 6x and we have a -3x. So basically, we're going to go 6 minus 3. 6x minus 3x Leaves you with just a 3x, and then you have to bring down the plus 2. So that's simplified now. So now what we're going to do is evaluate it as if x was equal to -1. So we're going to plug -1 in there and then add 2. So 3 times -1 plus 2. So 3 times -1 is -3. -3 plus 2 is equal to -1. So that's what we're looking for on that first one. Okay, now I don't have very much room over here, so we're going to do number 4 way over here. Okay, way over here. Now, we need to combine the like terms, and let's start with the squared. Let's start with the exponent with the biggest, the term with the biggest exponent. Right, so we have a negative 7x squared. Okay, let me redo that. A negative 7x squared and just a positive 1x squared. So it's going to be negative 7 minus 1, which is negative 6x squared. All right, and then we have nothing to combine with the 5x. So we're just going to put the x to the first next. And then we have the 4. Don't forget about this 4 right out here. So we're going to say plus 4, like that. So now again, we're evaluating it when x is equal to -1. So it's going to be negative 6 times -1 squared. Plus 5 times -1 plus 4. So -1 times -1 is positive 1. So negative 6 times 1 is negative 6. And then we have 5 times -1, which is negative 5. And then we bring down the plus 4. So when we combine those, negative 6 and negative 5 makes negative 11. Negative 11 plus 4 is negative 7. Okay, we are going to go ahead and go down to, turn the page. We're going to go to the example for connecting to real life, okay? So we need to understand the problem, we need to make a plan, and then we need to solve the solve and check. Okay, so each person in a group of 5 bought an evening ticket to the movie, okay? A medium drink and a large popcorn. How much did the group pay in total? Okay? All right, so we've kind of broken this down. We need to know the number of tickets times the cost of each ticket, the number of medium drinks times the cost per medium drink, and then the number of large popcorns times the cost per large popcorn. So the number of tickets, right, we got 5 people. So that's going to be 5 people times the cost per ticket, evening ticket, right? So the evening ticket is $7.50. Okay, so the number of medium drinks, still 5 people. How much is the cost of a medium drink? It is $2.75, right? I forgot to put a plus in there, but yeah, we're adding. How many large popcorns? 5 people. Right. What is the cost of a large popcorn? A large popcorn is $4. All right, so if we multiply that together, I'm going to redo that whole bit right there. So we're going to evaluate this as if we're going to write an equation to be able to get this and solve it in case we want to change the number of people. Okay, so the number of tickets, we don't know. Let's say it's X, but we do know the cost per ticket evening ticket is $7.50. And then the number of medium drinks, let's call that X. Okay. And how much does a medium drink cost? A medium drink costs $2.75, right? So we do have to multiply there because that's how much it costs per person. The number of large drinks, we're going to represent that with an X. The cost per large popcorn is 4. So that's going to be $7.50 X plus $2.75 X plus 4X, like that right there. Okay, so we represented all of those things, and we wanted to use an X in case next time there's a different number than just 5 people going. Okay, so then we're going to combine the like terms. All of these have a X in them. 750 plus 275 plus 4. So when you add those together, we get 14.25X, like that right there. Okay, now we know in this case that the number of people is 5. So we're going to go $14. Okay, let me fix that. Oh my gosh. Okay, so $14.25 times 5 people. Okay, so that's going to be a total cost of $71.25. That's how much you're going to cost for all those people. Okay. Now I want to look at number 6. Number 6 says renting a room for a party costs $500. During the party, each guest receives a meal and a dessert. The meals are $15 per person, and the desserts are $6 per person. So the $500 is like a flat fee. It's not per person, just a standard. Everyone's going to have to pay that. All right, so I'm going to do number 6 right up here. So that is like where it's like the starting place. Everybody starts at $500. Everybody has to pay $500 to rent the room, but then we have additional costs because of the $15 per person for the meal and the $6 a person for the dessert. Okay, so that's going to be $15 times the number of people plus $6 times the number of people, because it's $15 times the number of people that are coming and 6 times the number of people that are coming. Okay, so if I combine the like terms, the 15x and the 6x, we're going to add 15 and 6, so that's going to give us 21x. Okay, so that means $500 is everyone has to pay that right up front to rent the room. Then it's basically $21 times the number of people that are going to come. Okay, very good. Good. And we're going to skip number 7. And we're going to just finish up right there. And we're going to get ready to do an assignment. All right, great job, guys. Very good.